Hi guys, Mr. Bennett here. We're going to have a go at exercise 1A1 and also exercise 1A2. So these questions really ask you to go through the process of using the equation to find the curve. Right? So there's a few things that you have to do. So the first thing it asks you to do in exercise 1A is to use the information here to find the x-intercepts. Now the x-axis along here, we know that y equals 0 along this particular line there. Along that y-axis, we know that x is equal to 0 along that particular line as well. So the first thing we have to do is have to find the x-intercepts. So the x-intercepts occur when y is equal to 0. So in other words, your equation is going to become equal to 0 for x plus 2 x take 3. So for you to actually be able to find those when those are 0, so we can say either this value here is equal to 0 or that value there is equal to 0, or in fact both of them can be equal to 0. Now simply you don't have to do any more but to say x is equal to, now if I put the value of what value there makes that 0, well that's going to be -2, and or the value there will be x take 3, so it has to be 3 take 3 give you 0. So therefore my x-intercepts are those. My y-intercepts are going to be pretty easy. My y-intercepts are going to occur when x is equal to 0, and so therefore all I'm going to do is put 0 into the equation, so that will be 4 bracket 0 plus 2, 0 take 3, and so therefore that's going to give me 2 times -3 is -6, times 4 will give me -24. Okay, so I've now got my x and y intercepts. I could in fact put those onto the curve if I want to. So I have an intercept here at -2, I have an intercept here at 3, and I know this, it's not going to be the scale, but I've got a y-intercept at -24. Okay, now the next thing I need to be able to do to sketch this particular curve is in fact to do the axis of symmetry. So I'm just going to call that axis of symmetry, and that's going to occur when x is halfway between my two x-intercept points. Now if I'm looking at 3 and -2, that is a distance of 5. So therefore my particular value is going to be 2.5. So therefore my axis of symmetries are going to occur when x is equal to plus 1/2. So in other words, it's going to be 2.5 from -2 and 2.5 from 3. Now to find my y coordinate, that's my axis of symmetry, is simply my x value there. So simply come down here, I can even label that on my particular curve, and that's axis of symmetry, and that will be x equals to 1/2. Now the next thing I need to do is find the vertex point. The vertex point is the turning point. So my vertex, right, the axis of symmetry becomes my x coordinate. Okay, so in other words, I don't have to do anything about that. All I need to do is find my y coordinate now. So my y coordinate is going to be equal to, according to my equation, it's going to be 4 lots of 1/2 plus 2, and then it's going to be 1/2 take 3. Now whether you're good at fractions or not, it doesn't really matter. I mean, you can do that calculation on your calculator if you wanted to. So it's simply, all I'm going to have is really 4 times by 2.5. That's going to be 2.5 is like 5 on 2. That's going to be then also times by -2.5, which is going to be like -5 on 2. Okay, and so we could say 4 actually works out to be, if we're looking at it, works out to be 8 on 2. Alright? 8 on 2. So when we're timesing, we just simply times the top line together. So therefore that's going to be 8 times 5 is 40. 40 times negative 5 is going to be negative 200. And that's all going to be over 2 times 2 times 2, which is 8. Okay, now I think you can see there's a common factor of 4 in there. So that's going to be, well, how many times is 8 going to 200? That's the other question. I think you're going to get a value of negative 25. Okay, so therefore what I've now got is my vertice point. My vertice point is going to be simply a half and minus 25. So now all I have to do is put that information onto my curve. Alright, so again I've got pretty well everything there. I'll go to red colour, and you want to make it symmetrical. So it's going to go through here, it's going to go through there. It has to have the arrows on the end to say it keeps going. Label my vertice point 1/2 and negative 25. Alright, so there's an example, quite a hard example of actually drawing a sketch of one of these things here. Now, the second method here requires me to probably do a little bit less, and it's actually quite an easier formula to use, but to use this formula I have to have the vertice point. So the first thing I have to do here is to find my y-intercept. My y-intercept is going to occur when x is equal to 0. Right, so in this particular case over here we're going to have y is equal to 2 times by negative 3 squared take 1. So negative 3 squared is going to give me 9, times that by 2 is 18. 18 take 1 is going to give me an answer of 17. Alright, so my y-intercept, my vertice point is I'm going to get from my equation. So my vertice point I'm just going to read off from my equation, which is going to be 3 and negative 1. My axis of symmetry is in fact also read off the equation. That's going to be x equals 3. Alright, so this is my equation here. I've got my axis of symmetry. Alright, so my axis of symmetry is going to be x equals 3. I've got a vertice point at 3, negative 1. So that's my vertice point there. Alright, and then it's going to cut my y-axis at 17. So label that over here, 17. So my curve's going to go, and I'll do this in red again. It's going to go something like through here, right, and go there. And so that's my vertice point there, which is going to be 3, negative 1. Now, the key thing here is I haven't found my x-intercepts, have I? But I would have some x-intercepts simply, and I could find those quite simply by expanding that equation out. But that's not really what I have to do here to find my equation in most of the cases here. Alright, so that will be later when we start talking about completing a square and so on. So in these two exercises, what you have to do is really use the equations to find the curve, what the curve looks like, in predicting what the curve might look like. Okay, so good luck with those questions. Make sure you catch up with the teacher if you need some help with any of these questions.